So now we are going to look at a bunch of geometrical proofs using vectors. And it's just a process of writing certain things with vectors rather than just with coordinates. So here I've got two vectors, m and n, and they're position vectors, so this is our origin there. And what we would like to do is we would like to write mn in terms of m and n. So in other words, we want to start here and we want to end here. How could we do that by only traveling on the paths m and n? Well, we could do that by first starting at m and going back this way, getting to O, and then going along n and getting to n. And so we would write that exactly as we see it, negative m plus n. And then, of course, n to m would just be the negative of what we had started with. Now we're going to add a point P right here in the middle. Okay? And the idea is you're told you have to get from O to P, so this is what we want to do. We want to get from O to P, but we're only allowed to walk in directions of m and n. How do you do that? Well, take out a yellow. This should be nice and colorful. If I wanted to get from O to P, I'd start here. Can you see that I could go from O to M, and then I could head along the red direction and just go halfway from M to N? So how would I write that? Well, O to P is equal to O to M plus halfway from M to N. How does that work using just m's and n's? Well, we know that O to M, that was just m, plus half, and we know that m to n, since we figured it out earlier, was just a negative m plus n. If we distribute this half and simplify, we're going to get a half m plus a half n. So what does that mean? Well, if I go back to my diagram and erase all the colors I've had so far, put the point P right back where it was, right in the middle, and then I'm going to go on O to N, and I'm going to draw a vector halfway. And from O to M, I'm going to draw a vector halfway. And I'm going to say, if I add half of M plus half of N together, do I end perfectly at P? I do. And I've only traveled in the directions that I'm allowed. This one's fairly straightforward. We're going to do some fancy ones in a bit. So here we have A, B, and C have position vectors A, B, and C respectively. P is the midpoint of AB, and Q is the midpoint of BC. Find the position vectors P and Q in terms of A, B, and C. And then eventually, what we want to find is how can you go from P to Q traveling only in those directions? What would you tell someone to do? How would they get there? So I'm going to let you try this one. I'll put the answers up in a bit. Check if you got O to P and O to Q right. And then P to Q, well, that would just be going P back to O, and then O back to Q. You know that P to O is just the negative of O to P, and then adding O to Q to that gives us negative 1/2 A plus 1/2 C. Now, what does that mean on our graph? Well, if I draw, here I'll use purple. If I draw negative 1/2 of A, that would be that arrow. And then in another color, yellow, if I draw 1/2 of C, that would be that arrow. So that's saying if I start at P and I draw that arrow there, followed by this arrow there, does it match up perfectly to get me to Q? It does. And so I can get from P to Q only traveling in the directions that I was given. So now we can complicate things a little bit more. Oh, this one's not too complicated. This one's pretty easy, actually. The next one is going to be the fun one. So we'll do this one relatively quickly. It's a hexagon. So some things about a hexagon. There's a lot of parallel sides here. Can you see that each opposite side is going to be parallel in a regular hexagon? So if you needed to go from O to B, from here to here, can you see that you can get there by going A plus B? If you need to go from B to D, can you see that one way that you could get there is this way and then down that way? So what would that look like? Well, the first one was a negative B, and then we went 2 in the A direction, but negative. Okay? Can you see that you could have gotten from B to D going this way? Oops, I want to go red. Could have gone this way and then this way. Can you see that this one is a negative A? And this one would be a negative of, oops, A plus B that we found before. And if you combine those together, you're going to get negative B minus 2A. So depending on which pathway you choose, you'll find out that your vectors end up being the same thing. C to F. Can you see that C to O is the same as B to A? And so going 2 in that direction, you could write it just as negative 2B. Some things about a hexagon. If I draw one of these triangles, it makes an equilateral triangle. That's why all of those lengths are going to be the same. Could you have gotten from C to F in a different way? Yes. Can you see that you could have gone from here to here? That would have been an A. And then a negative B. And then this one is a negative A plus B. Combining all those together, and you'll get negative 2B as well. All right, now for some fun. We have got a parallelogram, so that means opposite sides are parallel and opposite sides are of equal length. And OA is vector A and OB is vector B. We're told that the point P lies on the line AB and is extended such that the ratio between AB to BP is 2 to 1. So that means if this is 2 units, this is 1 unit. We also know that the ratio between CQ and QB is 1 to 3. Now, I'm going to put a 1 here and a 3 here. I'm using different units now. I changed color because obviously, well, it's a little bit hard to tell. It might be that these are actual lengths, but they've just told us a ratio. So we have 1 of a different unit to 3 of a different unit, because it could be that we could still have that, but that 3 and that 2 don't necessarily need to have a relationship between them. So this is the information that we're given. And now we have to figure out each of these vectors from A to B. Eventually, we're going to want to figure out how to go from Q to P using only the vectors A and B. How do we go about this? Well, from A to B. So if you want to go here and here, can you see that you could get there by going negative along A, negative A plus B? That would be the vector A to B. Now, if we know that that's the vector A to B, how could we go from A to P? How much further along do we have to go? Because A to P is parallel to A to B. It's going to just be longer. In fact, it's going to be A to B times something out in front. How much would you have to multiply A to B in order to get that ratio of 2 to 1? 1.5 or 3/2, right? And so if we multiply that through, we're going to get negative 3/2 A plus 3/2 B, because we had figured out A and A to B earlier. Now that we have A to P, we can figure out our position vector from O all the way to P. How could I get from O to P? Can you see that I could get from O to P by going from O to A and then from A to P? And O to A was just A. And A to P we had figured out already. Adding those together, we've got negative 1/2 of A plus 3.5 of B. Just to draw that out, okay, this would be a negative 1/2 A. This would be 1B, and this would be another 1/2 of B. Doesn't work out. If I go negative A, all those are grouped. There we go. I guess maybe if I drew it, had drawn it a little bit better, it would work out nicely. All my other ones so far worked out really nice, but it was supposed to line up perfectly. And now, similarly, we can figure out O to Q. How can we get from O to Q? Well, O to Q would be going from O to C plus going from C to Q. That makes sense. And since O to C is parallel to A to B, we can say that that's the same as going from A to B plus, and C to B, how far along is C to Q? What number would I have to put in front of C to B? Close to 1/3. This is the one thing with ratios that gets you mixed up. You want to say 1/3 because of the ratio, right? But how long is this whole thing? 4. And so the ratio of 1 to 3 makes you go 1/4 of the way from C to B. So A to B, well, A to B we already figured out. A to B was negative A plus B plus 1/4, and C to B is parallel to O to A, 1/4 of A. So put that together and we will get negative 3/4 A plus B. So now we have O to P and we have O to Q. We've got the green position vector there, and we now have this blue position vector there. It says, hence, show that QP is 1/4 A plus 1/2 B. So Q to P is the same as going back to the origin and then going from origin to P. Q to O is the same as negative O to Q. And now we have all vectors that we've already figured out. Negative O to Q will be that. O to P putting things together, we're going to have 3/4 A minus 1/2 A, which I'm going to write as 2/4 A. We're going to have a negative B, which is negative 2B over 2 plus 3B over 2. So we get 1/4 A plus B over 2, or 1/2 B. Sometimes they'll have something that says show that, and then you know that that's what you need to get. And sometimes they include something like a show that in the middle of the question because you need to use it for the next part. And then they know that you at least have the right answer to use for the next part. So what does that mean? If I draw 1/4 A along here, so if I take A and split it into a quarter, that's about 1/4 A. And 1/2 of B, and I move these vectors accordingly. Close. It might be that my diagram isn't actually drawn to scale, and that's why these aren't matching up perfectly. But it gives you an idea. You could get from Q to P traveling only the directions of A and B, and that would be the way that you could go about doing it. So last one, again, draw a diagram. Here is our rectangle O, A, B, C. I don't know if this is to scale. We're going to find out. O to A has a length of 8. Yeah, it is definitely not to scale. There we go. Figured that out right away. And A to B has a length of 6. Vector OA is A. So we're going to call this vector A. And O to C, this is going to be vector B along there. Express the two diagonals in terms of A and B. So this right now is A, this right now is B. One diagonal is O to B. And if you had written B to O, that would have been fine, just as long as you defined it somehow. How can I go from O to B using A's and B's? Can you see that you could go A plus B? And our second diagonal, if I do A to C, well, I could get there by going negative A plus B. Now, how long is it from O to B? Well, if I think of this as my origin, and this is a length of 8, and I think of a coordinate system, does it make sense that point A here would be at 0, 8? And point C over here would be at 6, 0. Well, we could change those and now think of those as vector A as a column vector 0, 8, and vector C as a column vector 6, 0. So how long is O to B? Well, O to B is equal to A plus B. And if you added A plus B, you'd get that vector, 6, 8, which makes sense, right? 6 to the right, 8 up. And if you figure out what is the length of OB, no equal sign in between there. Well, that'll just be the square root of 6 squared plus 8 squared. Maybe recognize that as the 3, 4, 5 triangle, and you get 10. What is the length of OB plus CA? Well, O to B was A plus B, and CA would be a negative of this, so that'll be minus B plus A. Simplifying that out, we're trying to find the length of two A's. What's the length of one A? 8. So two A's will have a length of 16. Of course, you could have done your column vectors to figure that out as well. If you went from O to A, then A to C, and then C to O, where would you start? Where would you end? Where do we start? At O. Where are we going to end? Uh-oh. Which is equal to your 0 vector. Nice. And that is where we are going to stop.